So hello, welcome to Trigonometry Summer School. And here we're taking a course through Confer Zoom. I am excited to work with you guys this summer. This is one of my favorite courses. It's one of my favorite courses because it kind of is a little different than what you've probably been used to with algebra, but it does use a lot of algebra in it. And so you got to remember certain things from algebra, but as I go through the course, if there's certain material that we have to know from previously, I will kind of say recall, or it's just in time remediation. This is how you do this, remember. And if it's something that's going too fast for you, you might have to come back and rewatch it. I can lead you guys to supplemental areas outside of class, good videos, good instructors that could also watch videos of someone else lecturing on the same thing. You guys also have a tutor that is, I'm sorry, I'm just looking to see if I see that they're on here or not. They were going to try to come in today and introduce themselves, but they had something at this time, so I don't see them in here. But I believe you have, actually, I don't know anymore. I don't know if it's Amber or Zachary for your class, sorry. So you have a tutor on your, let me see if I can pull it up and share. Okay, so right now you should be seeing my home screen or my screen. This is where you had come in to get to the lecture that you're at right now, and you're not seeing it because I didn't say share yet. There we go. Okay, so this is where you had come. This is the Canvas page. This is where you're going to get information. So for instance, your syllabus is under there, any important announcements. I had posted a couple videos in here before the semester had started, and so you can go to those. Unfortunately, this one I had posted last night, I guess some people were having problems getting into it, so I have a new link in here. But basically, this was just telling you guys how to get to your class period and a little bit about your class and telling you that you had your syllabus in here. So there are a couple different assignments that you're going to have. Some of them are going to be through Canvas itself like this. So an assignment about your syllabus. So you can click on this. This will bring you to the assignment. And basically, and you can just read through it, but you're going to basically read through the syllabus. You're going to have it printed off, and you're going to initial each item saying that you understand what it is saying. And if you don't understand what that portion of the syllabus is saying, put a star by it, and on a different sheet of paper, because you won't have room on that, put down your question or what you want clarified. And so this assignment is due on midnight tonight, 11:59 tonight. And you're going to upload that. This isn't my thing. Okay, and that just brings the syllabus. I'm not in the student view, so it might look a little different than what yours does. Okay, so that is where you would find some important information. Going back to home. Weekly class information. Okay, so this is where I'm going to start posting because I really did not plan exactly how many sections I'm getting through a day. I know with your class trigonometry, I need to get through about 2 or 3 sections a day in order for us to keep on track. But as we go through the days, I will post the sections in here. And then if we did any in-class exercises, then I would post what we did here. If you miss class, sometimes you'll be able to make them up. For instance, if it was a worksheet that you guys were working on, you can make it up and turn it in for most of the points. But there's other times that we'll be playing games and stuff, maybe Kahoots or Quizlets, and that's something that you would not be able to make up the points for. Okay. So I'll just continue as the week goes on, the day fills this information out for you guys. And then the last category, which I have not updated yet, are reviews and materials of old exams. I've taught this class many times. The problem is that in this semester, I've decided not to give 4 exams and the final. I'm just decided to give 2 exams and the final. So it's a lot more material than what a normal semester's exam would look like. So just as you are reviewing those, just keep that in mind. Also, the way and format that I'm giving you the exams is different than I would have given to you in class. So last semester when I gave exams, they were mostly through Mymathlab, where the students went into Mymathlab, did the exam at a particular time. They had a time limit. They were working out the solutions as they were going through the exam on paper. Right after they finished and submitted the test on Mymathlab, they uploaded the work onto Canvas so that I could grade and give partial credit. So that's probably what I'll be doing this semester. One of my classes last semester, I ended up giving my final exam was totally verbal for the class. And each student met with me for 15 minutes. And we talked, I randomly pulled one question out of like 350 questions for a student, random generator, and asked them that question to walk me through and to ask them questions about the course. And they would tell me about it. And that's how we did the final. So it's possible that one of your tests or some of your tests might be a verbal test. This semester, because you guys know that we are doing the class this format, I am going to have you guys have a webcam on you when you are taking your exam, and you're going to be taking your exam in class. I decided that we'll have our exams on Thursday, and your first exam will be next week on Thursday. And that's going to cover all the material that we get through this week and through Tuesday next week. What else do I need to tell you? Homework. So I don't have a particular textbook. Well, I do have a textbook, but you don't need the textbook. You'll be doing your homework through Mymathlab. This is the first semester I've actually linked Mymathlab up to the Canvas page, so you can get to Mymathlab through Canvas. And so here on the left tab, you can see Mymathlab. If you click on this, and this is going to again look a little different because I'm in an instructor view, not a student view. When you get in here, maybe I can, let me change it to a student view. So Mymathlab does cost money, and it really depends on, let me see, how many weeks. They've just started redoing things where it's now in terms of weeks and not by semester. If you are taking my college algebra class with this, because I chose the same textbook, you shouldn't have to pay for the access fee twice. Okay, so anyways, you would click on my lab and mastering. And if I open it up, it's going to ask you to go through, read through this if you want to read through this, and you're going to have to accept somewhere down here. Okay, so if you had a Mymathlab account before, you can put this in here and sign in, and then they will tell you what you need. If you haven't used Mymathlab before, you're going to create an account here. Once you've done this, it's going to ask you, I don't know if I can sign in, we'll try. Okay, so you can either purchase an access code through the bookstore, which is more expensive, but some students need to do that. Or you can use pay. This is where I was saying it depends on how many weeks you're going to use the book. If you are taking college algebra next semester, I am teaching this course, and so I don't know about the other instructors if they're going to use the same textbook, but if you're going to be taking it through me, you might want to get the 24 months. Otherwise, actually 18 weeks. No, that wouldn't work. Or do the $70. If you don't have the money right now, or for some reason you might think that this course isn't going to work for you in the summer, or if you just want to kind of try it out, there's on the bottom row here, there's a get temporary access without payment for 14 days. So basically you can get in, you can do all your homework or quizzes, whatever I put in there, the tests, until 14 days is up, and you'll keep on getting a reminder that you need to pay. And then from there, you can just use your credit card or use the access code. Okay. So let me see, let me get out of here. Okay. So that is pretty much kind of the layout of the course. Whatever I lecture and go through on Monday and Tuesday, the homework is going to be due on Thursday by class time. And then whatever I teach on Wednesday and Thursday, the lecture or sections, that's always going to be due on Monday by class time. Homework you can turn in late. It will knock off 20% of what you did not complete before the due date. So for instance, if you didn't get to the section at all before the due date and it passed, you can get back in there, and if you got 100% on it, it would knock off 20%, so you got an 80% on the homework. If you've only didn't complete a couple questions, maybe you had a question for a tutor or the class and you needed to go back and do it after the due date, then it's just going to knock off 20% off of that one problem or a couple problems you didn't complete. So I will let you guys read the syllabus and get more of a general idea on how I do things, and then tomorrow when we come back, I will already hopefully have read your questions that you had on the syllabus and things that you need covered, me to cover, and I will do that at the beginning of class. Guys, so let me stop the recording for a second. So right now we're talking about homework and how things should be uploaded when you're uploading it into Canvas. So any assignment that you're uploading into Canvas, it's going to make you do it as a PDF file, and you want to do it as a single PDF file. There's different softwares online that you can look up on how to do that. Just, we were having a discussion about being safe and what you're downloading on your phone or computer. Mymathlab, where you'll be doing your homework, again, that you can get through the Canvas page. You'll be writing up your homework just like you were writing up your homework from a textbook, and you're going to keep all that organized. For some reason, if Mymathlab did not save your work, right there you have proof that you did it, because you just did all your work on paper. That really has never happened before. I was told that it had happened, but the person didn't have any work to verify. And it tended to happen the whole semester for them, but they couldn't come up with a work. So you need that work for verification, and I can always go in and give you credit if that did happen. Throughout the semester, I might ask you to upload credit to get credit for written work. So I might say, okay, upload your homework that you did for 7.3 into Canvas. I created an assignment for that, and you would do that. Okay. Let's see. I don't know. So right now I'm going to get into, so you can kind of see what Mymathlab looks like. So trigonometry, you're going to see assignments here on the left. And then there's already some assignments in here. So right now I only have through only chapter 7, which is the start of trigonometry in this book.
You're not displaying your screen, just letting you know.
Ah, thank you. Okay, so now you should kind of see my screen. I believe when you get in here, it's already going to have you under trigonometry. And then again, this is going to look a little different because I'm the instructor, but you should see assignments here on the left-hand column. And when you click on the assignments, so far I've only posted what we're doing for chapter 7, but I have what I believe are the due dates where these are going to be due. As we move through, things might change, and then I would change the date. So just click on the assignment. It's going to open it up for you. You can kind of see it, maybe just see real quick. So one thing I really love about Mymathlab and online homework is the help features that you have. And so on the right-hand kind of top corner, you'll see a question help feature. And this question help feature will bring you to your textbook. It has a calculator and it has print. So some of you might not like to work on your homework on the computer. And so if you wanted to print out your assignment and do it on the paper and then go back to the computer and fill in, you can do that. When you push print, it's going to ask you, do you want to print just this question or do you want to print the whole assignment? And so if you print the whole assignment, you can work on it, come back and fill in your answers. So this randomly generates different questions or types of questions for each student. So your question might not be the same, exactly the same as somebody else's. But when you print it out for you, your assignment, you'll have the same thing when you come back in here. Okay, so if I wanted to do this, and I didn't know, maybe this does. Nope. I would just put this in here. So 180 degrees, which we haven't talked about, is, and let's say I said 3 pi halves. Okay, so this tells me if I'm wrong. So a lot of times you want to read why it's wrong. It could be that your answer is actually right, but you have put it in the wrong form. And so do that. So I could try again. And if I try again, this one only had one choice or one time for me to do it because it was a pull down menu. So a lot of times you have 3 tries, and then if you get it wrong, it will mark you wrong. So right now, you notice that it's a wrong question or wrong. It actually gave me back the same question. Let me try. So I'm saying 180 degrees is pi, and now it's telling me that I did do it right. So now you'll see that there was a green check on the left-hand corner telling me it was right instead of the X when I had gotten it wrong. When you leave an assignment, you don't actually have to save it. It will save it automatically. And when you come back, what you have done should already be in there. If you save it, it's going to come out with a score on that assignment, but it will raise as you go in and complete more of it. There's lots of different features on the left-hand side too that you can help you. This video and resource library is where you can get a lot of helpful tools where you could watch videos. So if you missed lecture or you needed someone else to explain it, hear it a different, maybe explained a little bit differently, you can go to the chapter, what section, and then what types of things that you want them to share with you. So here's the textbook, so you can see what is in the textbook. You can get videos, essential videos, activities, etc. So that's kind of just a little overview of, and there's all the information that they have on it. So a little overview of Mymathlab. Just a question to clarify real quick was on Mymathlab. You do have to pay for Mymathlab. You do have 14-day grace period that you can get in, do homework without paying for it. So you don't want to, you need to get that grace period and start on the work right away. After that 14 days, you do have to pay for it, and you are going to want to have this program because this is where your homework is, your possible quizzes, and probably where your test is going to be. Homework is 20% of your grade, and participation is 20% of your grade. If you don't do very well in math, these things right in here, if first of all, are going to help you be successful on your test and to learn the material, but it's also going to help carry you if you don't do well on your tests. So you can show me that you do know the material via homework and in-class exercise and stuff instead of under a testing situation. So those things, I would try to keep an A in those areas. And again, that could, really pull you through and passing the course at the end of the semester.
Can you show us on your screen where we need to, which one we need to buy? This is the 18-week one or whatever the solution was, the 6999 one, is that right?
Yeah, so actually that's your choice, the 18-week or the 24-week. If you are possibly going to be using the same book, then you would do the 24-week. But if you're not planning on taking possibly like college algebra with me in the fall, then probably the 18-week would be good. I believe the code for the 24-week is just for the same textbook that we're using, and it's not for any math course for the 24 weeks.
Okay, so when you pay for it, initially it just does both classes if you do the 24-week, because I'm going to come back probably in fall to do the rest of the class, and so this case I should buy this one and it'll cover both classes?
So if are you taking a college algebra in the summer too? With this course?
No, I'll be taking it in fall, I believe. It's in the one after this one. I think it's calculus. I don't know. I forgot, but yeah.
So calculus, we use a different textbook. So the code, the 18 or the 24-week, I don't believe would go towards the calculus book.
All right, cool. Thank you.
You would want to do the 18-week. And then for calculus, if you're taking calculus through us, since we use the same textbook, once you get into calculus, you probably want to do the 24-week. That would save you money. Other questions?
Yes, I wanted some clarification on the single PDF file.
Yeah. So when you're uploading any of your written work or any assignments onto Canvas and it's telling you to upload a document, you want to upload it as a single PDF. So if you don't have a scanner, that's fine. People have used their phones before and just taken pictures of their document, or they've used their phone to kind of scan it, and you have to find the app that would work and do that, but there's many of them out there. and convert it to a single PDF before you upload it.
So if we, let's say like on the syllabus assignment, if we just like took each picture of like one page of the syllabus and then like made each one into a PDF, but then like upload it as like separate pages instead of like one whole thing.
Yes, you want to do, so that's a great question. I want them as one PDF, so each page isn't going to be a separate PDF. And there's, again, there's apps out there that will take multiple pictures and put it into one PDF.
Okay, thank you.
You're welcome.
For this assignment, the syllabus one, I'll download the app and everything, but could we just get feedback if it like turns out right? So will it look like one page, just like with a bunch of little pages on it?
No, well, usually when I see it on mine, it's like each page I will scroll down. So your one picture is one page, your next picture is the second page, etc. And then that is nice for me because I can make comments on your each page, especially when I'm grading exams and stuff. And I couldn't do that when it was pictures. I couldn't make the comments on the pictures. And again, it's just easier for me if everything is in one document and I'm not clicking and opening up everything, different things. Okay, so I think let's,
Can I ask one more question?
of course.
So we're going to be doing homework on Mymathlab, and then in addition to that, you said that if we get homework Monday and Tuesday, it'd be due Thursday. What do you mean by that?
So the homework that's assigned on Mymathlab, the sections that we cover in class that I lecture on Monday and Tuesday, you'll have sections on Mymathlab for those, and you're going to have those due on Mymathlab on Thursday before you come into class.
Okay, so it's basically what you're lecturing about. Okay,
Right.
got it.
Right. So right now, my plan, I think on Mymathlab, it says that I am going to get through 7.4s, 7.1, 7.2, 7.3, 7.4 due on Thursday. But if for some reason I don't get through that many sections, I would put that on that weekly portion of the Canvas page, what sections I actually got through that day. So you know, okay. That's the homework that's going to be due
Got
either
it.
Thursday or Monday.
Okay, thank you.
You're welcome. So, okay, so we're starting to get into the material of the course, the fun stuff, the mathematics. And so we're looking at the first section that we're going to be covering in this course, which is 7.1 from our textbook. But it's covering angles, arcs, lengths, and circular motion. Before we do this, actually, let's go through what we're going to be learning in this section. And then this section has a lot of terminology and definitions that I need to quickly go through. But we're going to talk about what an angle is, degree measure. We're going to convert between decimal and degree, minute, second measures for angle. We're going to find lengths of an arc of a circle. We're going to convert from degree, radians, and degree, from radians to degrees. We're going to be able to find the area of a sector of a circle and find the linear speed of an object traveling in a circular motion. Okay, so terminology. So if we looked at a line and we actually stopped the line at a point. So let's say you had a point and then you had from that point a line extended. So this is called a ray. And this point here is called the vertex. Okay, so if we took this ray and we maybe rotated it and formed a different ray from the point V, let's call this point V. this is called our angle measure between the two rays. Good. Let me just have my stuff in front of me. Sorry. Okay. And now I'm stuck. Okay, let's just start. Okay, so then we have this angle measure. If we took a ray and we rotated it, the ray that we started at, this is called the initial side. And after we rotate it and we stop, this is called the terminal side. If we're rotating it counterclockwise, we say that our angle measure is positive. So the angle is positive. So angles are positive if you are rotating counterclockwise. And they're negative if you rotate clockwise. I just want to get to just make sure I'm covering everything. So this is actually, I'm covering this course out of a new textbook, so they cover things a little bit differently than what I'm used to or have been doing the last 4 years. So I just want everything in front of me. Okay, so if we looked at the initial side, we took our ray and we rotated it all the way around. This is one full rotation. Which is equal to 360 degrees. A lot of times we're going to take our ray and we're going to put it on where our point is on the origin of our X and Y axis, and we're going to extend it to the positive direction on the X axis. If we put our ray here, this is in standard position. So usually, a lot of times we're going to look at it where we're starting in standard position and then rotating it. So again, positive if we're going counterclockwise and negative if we're going clockwise. And when we look at our ray and we rotate it a certain amount, we a lot of times say where the terminal side lays. So remember that there's 4 different quadrants. We have quadrant 1, which is in the upper right-hand corner when you're looking at the X and Y axis. Quadrant 2 is in the upper left-hand corner. Quadrant 3 is on the bottom left-hand corner, and quadrant 4 is on the bottom right-hand corner of the X and the Y axis. So if it doesn't lie, the terminal side, once we rotate it in one of the quadrants, then it's going to lie on either the X or the Y axis. So if the terminal side lies on either the X or the Y axis, we say that those are quadrantal angles. So quadrantal angles are angles where the terminal side lies on either the X or Y axis. Okay, so we talked about one full revolution is 360 degrees. There's a couple of different ways that we can define angles. So right now we're defining them as degrees. Another way that we can define degrees is that we can break it down to degrees, minutes, and seconds. That's a lot of times is used in navigation. And then another way that we can do angles measures is in radians, which we'll also talk about. Radians are real numbers and they're not degrees. And so a lot of times in mathematics, it's easier if we need to look at it as real numbers and not degrees. But we'll talk about that in a minute. But let's talk about degree measure. We just said that one revolution, so full circle, is 360 degrees. We say that 1 degree is equal to 60 minutes. Okay, so for notation for minutes, you're going to put a little dash there. So 1 degree is equal to 60, and then kind of put a dash in the superscript area. So this is our notation. If we look at 1 minute, so I would write that as 1 with that dash up there in that upper corner. This is equal to 60 seconds. So for notation wise, when you're looking at seconds, you are going to write it instead of 1 dash up there in the superscript as 2 dashes up there. So we have 1 degree is equal to 60. I'm sorry, 1 minute is equal to 60 seconds. So a lot of times in mathematics, we want to convert things back and forth into different forms to make them easier for us. And so a lot of times we do is manipulate things by multiplying things by 1. So if we know that 1 degree equals 60 minutes, well, another way to write 1 is to either divide both sides by 60 minutes for this equation or divide both sides by 1 degree. And so notice here, we can say, okay, let's just write it. So 1 degree equals 60 minutes. So the 6 with the dash, 60 with a dash there. If we divide both sides by 1 degree, notice that another way that we can write 1, and if we multiply something by 1, it remains the same. We can say 1 is the same thing as 60 minutes over 1 degree. Okay, so let's do that same thing. Or we could have converted it where we had, so we had 1 degree, right, equals 60 minutes. If we divide both sides, actually that's just 1 dash. If we divide both sides by the 60 minutes, another way to write 1 is equal to 1 degree over 60 minutes. Okay, so another thing in mathematics, a lot of times we want to convert from maybe feet to inches, miles to inches. And so if we multiply that by these ones, and we can cancel out our units so that it gets to where we want, and I'll show you that in a minute, that's helpful. So being able to convert these ways of writing 1 in a different manner so that when we want to convert something, our units would cancel out and give them to us how we want. So just do the same thing with seconds. So for seconds, we know that 1 minute, so that's a 1 with a dash in the upper right-hand corner, is equal to 60 seconds. So that's a 60 with the 2 dashes in the upper right-hand part of the 60. So if we divide both sides by either 1 minute, so if I divide both sides by 1 minute, I know that 1 is another way I could say is the same thing as 60 seconds over 1 minute. Or if you had divided both sides by 60 seconds, we can say that 1 is the same thing as 1 minute over 60 seconds. So let's say I wanted to convert, so how many seconds are there in a degree? Okay, so let's look at what we know. So we know that we want to know how many seconds is in a degree. Well, we know that 60 seconds, right, all over 1 minute. So if we want to convert minute to degrees, well, I also know that 1 minute, and I want the minutes to cancel. So I know 1 minute is equal to, I'm doing this right. Now I'm stuck. Okay, I know how many seconds are in a degree. Let me just redo this. Okay, so how many seconds are there in a degree? So I just, so we're going to do this again. So we know that 1 degree is equal to 60 minutes. And so we want to convert this 60 minutes into seconds. And so I know that I want seconds in my numerator, and I need minutes in my denominator. And so I need to rewrite this as 1. Well, I know that 60 seconds, so 60 seconds in my numerator, all over 1 minute in my denominator. And so notice think of it as my minutes cancel out. And so I have 1 degree is equal to 60 times 60. Well, 6 times 6 is 36. And then I notice that I end with 2s, I'm going to end 2 zeros. So 1 degree is equal to 3,600, and I still have my units of seconds. So another way that I can think of this is if I wanted to convert from degree to seconds or seconds to degrees, we can think of this, if we divided both sides by 1 degree, I can say another way to write 1 is 3,600 seconds all over 1 degree. Or another way to write 1 is 1 degree over 3,600 seconds. Okay, so we want to be able to go from degrees, decimal degrees, to degrees with minutes and seconds. And we also want to be able to go from a degree that's in minutes and seconds to a decimal degree. So let's just look at an example real quick on doing that. So let's convert 19 degrees. So you're gonna have a 19 with that little circle in the upper right, 35 minutes, so 35 with that little dash, 4 seconds, so 4 with the little 2 dashes, to degree decimal form. Okay, so we have the 19 degrees. What we need to convert is the 35 minutes, and we need to convert the 4 seconds. So I'm going to convert both minutes and seconds to degrees. Okay, so let's first look at the 35 minutes. We wanted again to convert this as a degree. So if we think of this again as multiplying by 1, and a fancy way to write 1, I know that I want my minutes in the denominator. So 1 minute in the denominator, and I know I'm trying to get to a degree. And so I know that 60, or sorry, I'm not gonna have 1 down there. I know that 60 minutes, or sorry, I know that 1 degree all over 60 minutes. That's another way that I can write 1. So my minutes are going to cancel, and I'm going to be left here with 35 over 60 degrees. So this would have been nice if I had my calculator with me. So let me pull out my calculator, and we want to look at, and we could reduce that. They're both divisible by 5, but we have 35 divided by 60. Okay. So I'm not going to round right away until the very end. So let me go back. So sometimes it's really important that you actually don't round till the very end. So let's just reduce this a little bit. 35 and 60 both have 5 in common. 5 goes into 35 7 times, and 5 goes into 60 12 times. So we just found that our 35 minutes was equal to 7/12 of a degree. And now we need to look at what the 4 seconds is. So 4 seconds. We need to convert this to a degree. So we can do what we just did before, where we just figured out that seconds, and we want seconds in the denominator, is the same thing. We can say 1 is the same thing as 1 degree over 3,600 seconds. So if I multiply this, 1 degree over 3,600 seconds. So our seconds cancel and we're left, well, 4 goes into 36, I know 9 times, I'm just reducing. And then we have 2 zeros left over, 1. So 1 over 900 degrees. So basically, if we add all of these together, we can say that our 19 degrees, 35 minutes and 4 seconds, this is equal to our 19 degrees plus our 7/12 degree plus our 1 over 900. Yes, degree. Okay, so basically if I add all those, I'm going to have this in terms of a decimal. Sorry, I'm also learning how to maneuver two screens. Okay, so if we had 1 divided by 900 plus, what was that? The 35 over 60. We're getting 0.58444444. And this tells me probably to round somewhere. Yeah, it doesn't. So this is 19 degrees plus 0. What was it? Sorry, 58444. So 4 with that is repeating. We can define that by a bar over it. So that number with a bar over a horizontal line over the 4, that's telling me it's repeating itself. And so we can say this is the same thing as 19.584 repeating. So the bar over it, degrees.
Can you scroll up a little bit so we could see the equation as well as the solution?
Yeah.
I mean, the question.
Yeah. Okay. So we were converting the 19 degrees, 35 minutes, 4 seconds to degree decimal form. And so we just kind of went back and we kind of nitpicked it. So we just looked at the 35 minutes and converted that to a degree. And we took the 4 seconds and converted it to degrees. And we did that by multiplying them by a special way to write 1 in order that our units would cancel and give us the unit in the numerator that we wanted it to be left with. So we should be able to go backwards. And so we should be able to take a decimal degree and be able to rewrite it in terms of a decimal minute second angle measure. Okay, so let's look at the following. So if you have 58.201 degrees, and this wants us to convert to DMS. Okay, so I've never seen that in this notation, but the DMS, they just, so we didn't have to write degree, minute, seconds, had the capital D with the degree symbol, M, capital M with the minute symbol and S with a second symbol. Well, we already have this whole number, the 58 degrees. We need to figure out what 0.201 of a degree is in terms of minutes and seconds. So we're okay with the 58. Right now, we're just gonna manipulate, work with the decimal piece. So we wanna convert first this 0.201 degrees into minutes and seconds. Okay, so I want to multiply this by kind of a fancy way to write 1. I know that I need degrees in the denominator. And so I know I also want to convert this into minutes. And so minutes, I know that 1 degree equals 60 minutes. So I'm going to have a 60 minutes in the numerator. And so our degrees cancel, and I'm left with 60 times 0.201. Okay, which gives me 12.06. Minutes. Okay, so I'm okay with a 12-minute piece, but I'm not okay with that 0.06 minute piece. So I want to convert that 0.06 minute into seconds. And so far I have this 58 degrees plus what we just found, the 12.06 minutes. And so now we're going to convert the 0.06 minutes into seconds. Okay, so I have this 0.06 minutes. And so in order to convert it, I know that I want minutes in the denominator. And I know that 1 minute is equal to 60 seconds. So I want seconds in the numerator. And so my minutes cancel and I'm left with 0.06 times 60. Okay, so we can do this without a calculator. We know 6 times 6 is 36, plus the 0 from the 60. But I have a decimal, and that decimal needs to be moved 2 places to the left. So this gives me back 3.6. Seconds. So putting it again all together, we have the 58 degrees plus the 12 minutes plus what we just found, the 3.6 seconds. And so we could just write that now as a single value. So this 58 degrees, the degrees, 12 minutes, and 3.6 seconds. Okay, so we just went from converting from degree, minute, seconds to decimal degree and vice versa. And now we're going to look at converting from degrees to radians. Okay, so how to define a radian. So 1 radian. Okay, let's look at a circle. So if you had a circle, and we're looking at the radius here, r. So the radius is that length between the center of the circle to the edge of the circle. If you looked at this length r, and you took that distance, that whole distance, and we mapped it on that length on the circumference of the circle. So if I took this length r here, and I wrapped it around part of the circumference of the circle until r was done. So that looks about the same length as this, right? If I took that string and I put it here, started it here, and then wrapped it until the size of the radius. That is what 1 radian is. So 1 radian, and this piece right here on the circumference, this is called the arc length. So when the arc length is equal to the radius, the measure of the angle is 1 radian. Okay, so when we're denoting in radians, usually we don't write radians after it, and we know that it's not in degrees because we don't have the degree symbol there. So basically, let's see how many about radians would go around a circle. So if I took this length of my radius and I took it from the end of where that arc length was, from where the start, the end, that length of the radius, and then I went out and I did another radius length on the circumference of the circle, this would give me, so this one piece is 1 radian plus the second piece, this would give me 2 radians. So this angle from here to here is 2 radians. If I did that again and I took the radius and I started from the end of the second radian, mapped it around the circumference, we get 3 radians. So it ends up that when you do this all around the circle, well, and I'm a little off, you should get a little over 6 radians. Okay, so let's continue to talk about that arc length. So again, that arc length is just a segment of the length of the segment of the circumference of the circle. So a circumference of a circle. We've learned before in geometry that the circumference of a circle is equal to 2 pi times r. So basically, if I took this arc length and went all the way around here, this is equal to that arc length in here is equal to 2 pi r. Okay. A little stuck right here too. Okay, sorry, I'm sometimes get a little bit stuck on how I'm going to explain things. So basically, again, we're talking about the circumference of a circle. This S here, that a lot of times in this book or in trigonometry represents arc length. So S is equal to the arc length. And when we're talking about the circumference, well, if you went around the whole circle, we know that the arc length of that whole circle is equal to 2 pi r. We learned that in geometry. Well, 2 pi, that, notice here, that's if we went around the whole circle. And so if I do a portion of the circle, instead of doing 2 pi, I'm going to do times theta. So 2 pi is the angle if it was a full rotation. And so if we want just a portion of a rotation, so finding the arc length, I'm going to blow this up so it's thicker. So finding the arc length, capital S, this is equal to theta times r. The thing is that theta has to be in radian measure. So remember when I was saying that if we looked at taking the radius and we took it and put a string and put it around the circumference of the circle, that we were going to get about 6 of those, a little over 6. Think about 2 pi. 2 times pi, pi is about 3.14, right? And if you multiply 2 times 3.14, that's a little more than 6. And so a full rotation around the circle is a little more than 6 radians, which is the same thing as 2 pi. So this is a formula right here that the arc length, we can find the arc length, the length of that sector kind of on the circumference of your circle by looking at theta, which is your angle measure in radians, times what the length of your radius is. Okay, so if we want to convert from, again, from degrees to radians and vice versa. Okay, so again, let's go back to this thing. This was this formula. S is equal to theta times r, the arc length. Well, if S was equal to 2 pi times r times theta times r, and we divide both sides by r, we get theta is equal to 2 pi. So another thing that we can say is 1 revolution is equal to 2 pi. So we also know a full revolution is 360 degrees is equal to 2 pi. Radians. I'm just going to put radians here for a second, but I'm normally not going to write it there. So I can think of this just like we had done before. If we divide both sides by 2 pi, I could think of this as another way to write 1, or if I divide both sides by 360, I can think of this as another way to write 1. And so it depends on which direction we're going, but we can either say that 1 is equal to 2 pi over 360. And if I reduce this, notice 2 goes into 360 180 times. So 1 is the same thing as pi over 180 degrees. Or another way to write 1, so if I divided both sides by 2 pi instead, I would have 360 degrees all over 2 pi radians. If I reduce that, that would be 180 degrees over pi. Okay, so these are going to help us to convert between radians to degrees and degrees to radians. So if we want to convert 60 degrees. So there's going to be certain angles that we're going to get really, really comfortable in knowing, and 60 degrees is one of them. And so if we wanted to go from 60 degrees to radians, again, think of it as we want to cancel out units, and so degrees is going to go on the bottom, and so that's 180 degrees on the bottom and pi on top in the numerator. So reducing, 60 and 180 both have 60 in common, and so 60 goes into itself once, and 60 goes into that denominator 3 times. So we know that 60 degrees is the same thing as pi thirds radians. So maybe just go through the couple of the ones that we really need to know. So 45 degrees is another one that you should have memorized. But for now, in order to convert, we can always multiply. But a fancy way to say 1 in degrees, so goes in the denominator to cancel out. So we have 45 degrees times pi over 180. Well, 45 actually goes into 180 evenly. It goes in there 4 times. And so 45 degrees is the same thing as pi fourths. So let's say I wanted to know what pi fourths was, not pi fourths because I just did that. Convert, let's say, pi 6 into degrees. So if I wanted to convert this into degrees, well, this is radians, so I need radians in the denominator. So that's pi in the denominator, and I need degrees in my numerator, which is 180. So notice my pi's cancel out, so that's nice. And then 6 actually goes into 180 evenly 30 times. So this is equal to 30 degrees. Okay, so it's really helpful to be able to go between, and this is what we're really gonna be doing more. We're not gonna be going a lot of times into minutes and seconds. Sometimes we need to do that, but more we're gonna be converting between degrees to radians and radians to degrees. And so this is a really important formula to help you to convert. I want to stop there for today, just so that I can field any questions, last minute questions about the course for you guys. But we did not finish 7.1. We're almost done. There's a little bit more that we have to do in this section. Again, this is summer school, so we're going to be picking up the pace and going a lot faster than what we just did today. We want to make sure that you don't get behind. Get in and do the homework now. The students that I found that were successful in my classes in summer school basically got to know other students in the class and spent most of the time in the College Success Center and with tutors. And so unfortunately, you guys don't have that as much, that we're all together in the same room and can form those bonds, but you guys can do discussion boards. You guys can, you know, hook up together in different ways to work together. Also, you have the tutoring center. And so you have free tutoring, that drop-in basis that you can go and get help any times, well, when they're open, and those times are on the front page of my Canvas. And then you also have 2 hours scheduled each day, and the times are posted again, and the link or how to get into the tutoring session is on the front page of Canvas. So I'm gonna stop the recording here and take roll and answer any questions you might have.